the joy for me is like the sum of the parts with respect to creative capacity between humans and their augmentation, whether it's robots or software or anything in between. People by themselves cannot accomplish this stuff. Robots by themselves cannot accomplish this stuff. Us working together with these systems and with these technologies creates new knowledge in the world. And like, what better way to live a life?
모스트 보던 팟캐스트.
Welcome to Most Pattern, where we explore the why behind our built environment through design, development, and data. I'm Legal Lee, joined with Alex Yoon. And sorry our third co-host could not be with us today. We wish that he gets well very soon. Today, we're diving into the future of robotics, digital twins, and industrial automation with a true pioneer in the field. Brian Ringley is a distinguished product manager at Boston Dynamics, where he's shaping the world's most advanced robots. With a career spanning architecture, robotics, computational design, and industrial automation, Brian is the perfect person to help us answer the question, why is it taking so damn long for robots to build buildings? Welcome, Brian.
Thank you so much. Thanks for having me.
So for our audio-only audience out there, where does this podcast find you today?
In Lebo's apartment in Queens, which is, I remember I was looking at the address. I was like, it's in New York somewhere, right? I'll just go to the nearest Long Island Railroad stop. And then I saw the dash and I was like, Queens.
Which most people don't consider New York City.
What? Well, okay, like if you say like, if you live in the boroughs and you say like, I'm going to the city, yeah, then that's kind of like Manhattan versus the boroughs. There's different talks, but now that I'm outside of that and I'm on Long Island, not in Long Island, then when we say the city, then, the boroughs count.
You're in Long Island City. It's the city in the city.
Yeah, that could be confusing for our listeners out there. Should we spend a large portion of the podcast disambiguating Long Island from Long Island?
This is the hard-hitting education we do here.
And also, like, there's also the cultural boundary and the actual geographic boundary.
Well, most people see me and they're like, okay, he's from Long Island City. He's probably from Suffolk, all the way out there. Like, take a 3-hour train ride home every day to come to work.
I live in Montauk.
Yeah.
I am just barely over the county line in Suffolk, so I'm barely Suffolk. But happy to be Suffolk, because Nassau is just Queens.
So that's a perfect segue to our first question.
Is it?
It absolutely is. You started in AEC, now you're at Boston Dynamics doing robots. What was that breaking point that made you leave AEC?
Yeah, I mean, that's a breaking point. You've biased the question. Like, I left and it was a bad thing, and perhaps it was. But I think the moment was, it wasn't that, like, I can post-rationalize that and say that the last project I worked on had specific examples of why things can be frustrating in architectural practice. Mm-hmm. But I think the truth was that moment kind of came somewhat accidentally through the explosion of WeWork. Mm-hmm. And that's not like leaving the industry necessarily, but that was definitely the gateway drug to leaving the industry. And it was like, well, if everybody else is going to have a really good time at this company where it seems like no one is working and people are drinking during the middle of the workday, but also there's, what the truth is that Jason told me that they were looking at layout robots. And I was like, anything for like a mobile robot to break out of this fixed industrial robot box that I had been in.
Where were you before WeWork? At the
Woodsbaggin. Yeah. Which was an incredible, I mean, if you could be anywhere in architectural practice, like working under Shane Berger on that design technology team was really great. It's also a testament to Shane, by the way. So like, shout out to Shane Berger that like, he had a group of employees and then they went to WeWork. And then like the next group of people that came in kind of went into that next stage of that design technology team, all went to NVIDIA. Mm. And, there's one way to read that and just be like, oh, architecture can't keep talent. But really, like, I think it's a testament to that environment that they were creating talent that was sought out by people outside of the
So having been in that environment, what did you find special about it?
About
the context that Shane created.
Yeah. Well, one, he was just a good manager. I mean, he made sure that we were spending the full, like, 40 hours a week just contributing to projects. There was no bullshit, no administration. He completely protected us from all of that. No politics. He promoted our capabilities. It was a global team he advocated for us across the various studios around the world, so that he made sure that anyone who had a difficult problem could, like, come and use us. And, you have to make a sales pitch for that, because there is an internal exchange of, like, there is, like, that internal budget. We were like a service that had to be paid for. And if you can get away with, like, an intern that kind of knows Grasshopper versus, like, the professional, then you will. And that's just the free market. But yeah, he showed that we had value, and we really tried to, like Andrew and myself, Jericho Prater, there were like a few people that were really a core part of that team. We tried to have a strategy that wasn't just about coming in and kind of writing a script and solving a problem, but we tried to leave an artifact, and that artifact was like a user interface that didn't require computational expertise, documentation about how we built this and why, so that other people could kind of carry that forward. Andrew Human, of course, had been working with Human UI, and it was very UI UX centric. Like, obviously we had to make, like, the guts of the business logic with Grasshopper, but we knew that ultimately, if we were going to be successful and scale what we were doing, one is we had to leave behind, like, just a Rhino user interface. If they didn't know Grasshopper was happening, all the better. And then two was also capturing the knowledge from that. So if we, went over the course of, like, a couple quarters and we had hit X number of projects, we were also developing tools that would essentially identify anytime we hit. This is all credit to Andrew, by the way, who wrote the most insane scripts, like the most insane meta Grasshopper scripts. So it'd just be go through all the scripts we wrote for projects around the world and find any time we did something custom, aggregate all of those into one document. And then we could kind of come in and sit down and have a review. And it was always like 2 or 3 of us, so we could work super fast without constraints. And then say, okay, the next round of stuff that we want to publish to Wombat, which was, so it's a Rhino. I mean, it was a Revit plugin too, but it's a Rhino Grasshopper thing that's got to be zoological. And we wanted it to be a reference to Woods Bagot, which originated in Australia. Wombat's an Australian animal. And the W and the B, the WO and the BA even of Woods Bagot. It's the perfect app name. And frankly, the most underrated Rhino plugin name of all time.
It's probably also the cutest Rhino plugin mascot compared to a Grasshopper or others.
It is cute. They're like a cuboid. They're so thick. Where is it now? I think it's still sustained by that team. Shane actually recently departed, which was like big news, and he's in leadership at SOM now. Which, but as a side note, it's really cool to see this generation. I think just before us was a roughly late Gen X kind of computational design people taking leadership positions, like executive positions at architecture firms. It seems like there's no longer, there used to be kind of this ceiling, like you were like an IT person, and you couldn't be design leadership, you couldn't win business, you couldn't participate in that level of conversation. And I don't think that ceiling exists. Alexandra Pollock is another good example of somebody who's kind of risen through those ranks. There are a few others, and it's been really good to see.
Is that because computational design has become more accepted as a legitimate form of design?
Yeah, it's just because, like, there's only, like, so much time you can just resist that, like, computers are inherent to the way we work. Like, so it no longer makes sense to partition your business based on, like, people who are good at computers and people who aren't. It ceases to make sense. We'll see that with AI too. Where like right now everything that's AI is special, but it's just like somebody's using an advanced form of statistics, and that's going to kind of permeate through, I think, a lot of the stuff we do, and we won't have to have a name for it anymore. anytime you name something, it's like because it doesn't work yet, right? It hasn't been fully absorbed into whatever it's serving. That's the, not the joke, but like a very common refrain about like the definition of a robot.
Mhm.
It's just like something that's not valuable yet. And once it's valuable, you'll call it whatever it does.
So maybe that's a good point to segue to Spot, which I think we should really lay the groundwork for the listeners. Spot is probably what Boston Dynamics is currently most well known for.
Yeah.
It's a robot dog.
Yep.
Is it more than a robot dog? As someone who I could do help the job.
So much more. Yeah, it's a quadruped robot dog, Roboterhund in German, which is I think my favorite word for it. Yeah, so I discovered Spot when I was at WeWork setting a research agenda. We were interviewing superintendents about where they were having problems that might be solved by robotics. I think at the time we were called the construction automation team. It was WeWork, so the names and the management were kind of swirling, but at the time it was called construction automation. And I was looking at the notion of field robotics, the deployment of mobile robots. Could we work with early hardware vendors, a lot of them stealth, some of them quite successful today, some of them no longer exist, but it was a cool era to be able to engage with that. But one of the big problem things was WeWork had acquired Field Lens.
Great software.
Yeah. And Field Lens was like my first exposure to what is now like a very, I think, normal type of construction monitoring or construction management software, which is some piece of reality capture, like taking photographs or photospheres of a job site and then like pinning them to blueprints and having some way of tracking work in place primarily, but you can pin issues. And what I like about it, it's kind of like that was like the moment where location mattered. So you're locating data spatially, even if it's in 2D, still important. And also the era of the iPad, where like we have a device with enough like real estate on the screen that it's useful in the field to do that type of documentation work. So I was talking to a lot of supers about that process as part of those interviews, and it wasn't so easy, right? They were not wanting to, first of all, they didn't want to do it. It wasn't the most important thing to go around and take pictures of the site. They were like, I am on the phone all day arguing with people about paying them or not paying them. I'm managing a crew. I'm under an extreme amount of pressure to move fast. And then like, the end of the shift hits, I want to go home and see my family, and like I'm supposed to go do my site walk and take all these photos, and then the like Ricoh Theta won't connect wirelessly, and like my cradle point's not working. There were all these like, and I was like, okay, let's like latch in on this. And about the same time too, I was doing other research, like we were doing a lot of prefab projects, and we were looking at like, do a prefab toilet was one of the projects we were working on. Did you know that?
I did not know that. All I heard was you guys were putting chrome on robots, but I did not know toilets were involved. I would have been much more excited to actually.
God, that chrome never happened, and you're gonna give me post-traumatic stress disorder from that reference. But don't talk about the robotics lab. But there was a modular bathroom project, which was perhaps more practical than chromed industrial robotic arms, but they're not as cool. So I was like, oh, let's find, at the time we were going gangbusters, like in terms of all the projects, just in Manhattan, like walkable from headquarters. So I was like, let's find a project that has an open wet wall. And that's because I need to see like what the connections are going to be to the plumbing. And they're cool. Let's use Field Lens for that. And I'll just like find all the projects in my area, so the hot young singles in my area, the open wet wall in my area, and figure out like where I should visit to learn to like develop this product. And everything was so out of date. Like there were like huge holes, like information was missing. That's what spurred all these interviews. And then I'm, of course, this is like terrible to do. And I was like, this seems like something a robot could do. We tried RC cars, we tried drones, we did this, that, and the other. And eventually I was like, oh, legged robots. Like we need to be able to move through a unstructured environment that has stairs, that has like clutter all over the ground, that has gaps, that has ramps. Like at the time, like I knew what legged robots were, but they were kind of like exotic robotic morphologies that didn't have any like practical use.
But during that time, it was
Yeah.
when we were seeing all these videos from Boston Dynamics of like people kicking the dog,
Yeah.
people like throwing boxes at them.
Yes.
So like, what helped you make that connection? You're like, oh, okay, like I can kick this dog, but it can also take pictures of the web wall.
It was a 2018 Boston Dynamics YouTube video where they actually showed taking they were the alpha spots, so they were still black. They didn't have the yellow shells yet.
Mm-hmm.
And they were taking them through Japanese job sites. They were owned by SoftBank at the time, so they had access to some of the big Japanese contractors. There's a whole interesting story there about their history with robotics dating back to the 80s. And I saw that video and I was like, that might actually be worth pursuing. That seemed like a crazy idea yesterday, but today not so much. And we worked a bunch of different contacts because we were owned by SoftBank. They were funded by SoftBank, or vice versa. There was a SoftBank connection there somehow. And we ended up making that connection through Lincoln Wood.
Oh.
Yeah, so the story is like he was at Turner Construction before he started doing the West Coast WeWork construction stuff.
Mm-hmm.
And he had talked to Boston Dynamics, basically first. As far as I know, maybe the first big contractor to talk to Boston Dynamics, representing Turner Construction. I don't know what happened with those negotiations. But then he showed up on the scene and he was like, oh yeah, I know Rob Plater, the CEO, and Michael Perry, who then was really directing their business unit. So went down there, up there with Tim. Doomtrade. Yep.
Good friend Tim.
Yep. He was my boss at the time. And we got off at my favorite part of this story is we got off the Amtrak at Providence, Rhode Island instead of Boston. Only because everyone on the train got off and we were just like, must be Boston. So we called an Uber. We made it on time. Not like Waltham is in Boston anyway. So we went out to the office and talked with them, and they were really angling for the construction industry. Their hypothesis was that they would find product market fit in construction. And we started testing that out, and specifically like, okay, well, what's the application? This thing is a sensor, a mobile sensor carrier, mobile IoT, or dynamic sensing, as we ended up branding it. So what's a sensor that matters for construction? So it's like, well, I want to monitor progress.
Mm-hmm.
So we'll put a Ricoh Theta on there for 360 imagery. A laser scanner would be cool. And that was kind of the genesis of essentially how Spot, like the use cases for Spot in construction, which was a variety of ways to track progress in near real time with reality capture hardware.
So you talked a little bit about how Boston Dynamics and the WeWork relationship happened, but what motivated you to leave WeWork to go to Boston Dynamics?
Yeah, that's also an interesting story. Boston Dynamics reached out to me and they said, we're really pursuing the construction market and we need a construction expert to come on board onto the business development team, and to help us like really identify an application and build a construction specific project. Mm-hmm. And I said, cool, awesome. I know so many people. At the time, before WeWork had started to like collapse, this was like a little bit before bad things started to happen. I was like, well, the opportunity at WeWork is better because I'm using every construction robot. Like, I had access to the Hilti J-Bot before it was out of stealth, to the Dusty layout robot before it was out of stealth. Back when they were even thinking about that it was a Roomba for construction before they pivoted, which is kind of an interesting story. So I had access to all of these like really amazing technologies. One of the first people who got to use them and use them on site and measure their effectiveness. And I was like, well, this is the dream job, obviously. Why would I get married to one robot when I've got all these other robots out here I can date? And then push came to shove with WeWork, and I couldn't find anyone who wanted to take that leap actually, because in my mind I was like, this is awesome. And, you know, anyone's gonna like jump at the chance to work at Boston Dynamics. This will be no problem. No one really wanted to do it, and I kind of, in retrospect, it makes sense. It's like it's a pretty big leap of faith to build your entire career in construction and then to become like that construction expert, but really be entering the robotics industry. And thank God I didn't think about it too hard, because it probably would have also freaked me out if I really, it was like, well, what next? But like, then there was pressure at WeWork. It was clear that they probably weren't going to retain a lot of people doing research, stuff that wasn't core to the co-working space business. There was a micro pause there, because I was like, what did WeWork do? Like, co-working space, right?
Oh, you mean robots were not core to co-working?
Right, yeah, exactly. I was like, wait, what were we doing all that stuff for? You know, not to be too dismissive or glib, but it was clear that I needed to go somewhere else, that I would eventually be laid off, even though that was a pretty sweet severance package. It probably would have been financially advantageous.
One of my big life regrets.
Oh yeah, we were just too good to get fired. That's the problem. We had just performed a little bit less. We would have made out better. But so so at that point I was like, what if I took that job? And I did. And part of the resistance too was like, do I want to uproot my life in New York and move to Boston? And then ended up not having because of COVID and whatever. But so I finally like made that leap and was really, really happy with that decision, and really started working on like, what is the construction product for the Spot robot?
So I think earlier you said that when you were first talking to Boston Dynamics, like Lincoln Wood had already been talking to them, they had this hypothesis that, hey, Spot would be really useful in construction.
Yeah.
You now at Boston Dynamics in charge of proving out this hypothesis. So what happened? Was the hypothesis proven out? How useful is Spot on construction today?
Yeah, so we started with an early adopter program. I think we signed up like 10 GCs. There was a massive amount of interest. So like we started off very strong. We were engaging with a lot of the top general contractors in the world. Foster and Partners was involved early on too. They were the only early adopter, I believe, that was an architect, which is really cool. Obviously still working with their GC partner on site. So this was like right before COVID. We're going all over the world, delivering robots, getting people started. And at the time we were working with Hollow Builder, similar product to Field Lens. I think in that like particular domain, now we're probably looking at like Open Space as like the top product, but there have been a lot of players in that space. So we were working with Hollow Builder. They took a leap of faith with us to like build an application. And at the time, the Boston Dynamics SDK is pretty incredible.
What's an SDK?
A software development kit. So it's a collection of APIs and documentation so that you can build on top of, you know, the software that we use both to control the robot, to create software interfaces for the robot. So in this specific case, like Hollow Builder could use the SDK to build a Spot plugin. So instead of doing a manual job walk, you could do a spot walk. And a spot walk would allow you to use the robot to program a repeatable set of like photospherical captures, to use the location information or localization data of the robot to automatically pin those things to the correct location on the blueprint. So that's where we started. And we worked with the early adopters, and there was a little bit of a mismatch. And I think that this isn't really a mismatch in terms of the value it delivers. It's a mismatch in terms of how expensive and sophisticated the Spot robot was versus, I'm going to put like what's a Rico Theta? Like $1,000 at the most?
$200.
$200? Yeah. Okay. Yeah. So yeah.
Well, I mean, you work with robots, so
what is the cost of a sandwich? But like it was just this huge bit where like I think the perception was like, why am I putting such a cheap little sensor on top of this? This couldn't possibly be like the right use case. So we kind of got pushed toward like what's the most expensive sensor we can put on the robot, which is like a terrestrial laser scanner. which, are in the range of 60 to 100K probably per scanner, depending on what you get. So we started to move in that direction because people were like, well, if I'm going to invest in a fancy, relatively expensive in terms of the type of hardware they're using, although not significantly more expensive than like total stations and laser scanners themselves, then like it should be the Cadillac of sensors.
Who was pushing this? Like, was the customer like, wait, like this is too cheap. Please make it more expensive so it's more palatable for my spending.
Well, I mean, this is the benefit of hindsight. There was a lot of like factors going on at the time, and we were kind of following, the customers, right? Like, what do they want to pay for? What do they think is valuable? And they're like, oh, laser scanning is so labor intensive, and it seems like the right technology match for a robot. And I still believe that that's true. I just think that going on the premise of like the more expensive the hardware is, the more justified the use of the complex technology is. I think that was like that's like an economic thing at an early stage of a new piece of hardware that was maybe a little bit of a distraction, but nevertheless, that really kind of blossomed into an early market.
Mm-hmm.
And then we were talking with Faro. We had done an integration with the Faro Focus series. We were talking with Leica. We had worked with their RTC 360, and we were talking with Trimble. We were working with their X7.
These are all laser scanners.
Laser scanner models, yeah. For those, not in the know, dropping a lot of acronyms here. But they're all terrestrial, meaning that traditionally they're on tripods.
Mm-hmm.
So the idea of being able to, you're getting the mobility of a mobile scanner, but you're getting the accuracy of the terrestrial scanner. And
maybe a little sidebar, like, especially for construction, why is it so important for laser scanners to be stationary when they're doing their scans?
That's a yes. And is it really? So terrestrial scanning requires a series of static positions or stations. You set the scanner is stable on a tripod, because it's a very sensitive piece of equipment that's bouncing lasers off of things and needs to get really precise readings.
Mm-hmm.
So by virtue of being static, it's easier to measure the laser bounce, essentially, official term, laser bounce, technical term, so that you can get like, we're talking like sub 2 millimeter measurement. And if you really like know your stuff and have control on site, you can really tighten that to plus or minus 1 mil. And so it wasn't just the expense of the hardware, it was like the sophistication, the quality, the precision. Like, oh yeah, like we'll automate this hyper precise thing. And so that's kind of why we were focused there. Later we kind of learned there's some like lean manufacturing lessons about if you have a bajillion points in step 1 and step 2 is analyzing those bajillion points, you might be creating a bottleneck. You're just shifting the bottleneck from the field to the analysis, which isn't entirely a bad thing. If you can shift a bottleneck off site, that might be an improvement. But we signed an agreement with Trimble, and we built a product with Trimble. They had something called Field Walk.
Mm-hmm.
I just want to confirm, though, that what you're doing is in pursuit of more precise implementation. The construction methods and the techniques that are being applied are actually working.
Yeah, so it was, how is laser scanning of that precision used? Like, you typically do that once or twice in a project because it's a huge amount of labor to collect and it's a huge amount of labor to process. So you might do one at the end because you need like an as-built that's part of your contract. And you might do one kind of midstream just as a way of checking things. And a lot of this ends up being kind of tied to the contract and what's expected. Not many people do it in-house. If you're a big GC like Turner Construction, you will. But a lot of people outsource this and it's very costly. So what was attractive to me about this was that you could fundamentally change a technology, laser scanning, still a very new technology in terms of adoption in construction, to be clear. And you could change it from this thing that you do once or twice as like a check or a contractual obligation and just have it be this like background process that's always running. The digital twin, right? This is the like This is the physical to digital step. What if that was just always happening?
Mm-hmm.
And the way to enable that always happening was that you have these physical robot agents that crawl your site on a daily basis. There's no human labor involved, and you just get those updates. So that's what was really exciting to me. We ended up working with Trimble, building a product with them, and it was really successful in the first year. Like we sold a lot of robots, and we got a lot of customers into kind of advanced pilot phases where they were able to, there's the proof of technology phase where you're like, can my product even do this? There's the proof of concept phase, which is we're kind of babysitting this to make sure that like there's a real business case. It functions the way the customer expects, and we check some boxes in terms of what we agreed that this thing does. And then there's pilot where you're like, all right, I'm going to leave my baby with you now, and you're going to use this every day, and it's going to go into production. It's going to actually impact your business. And then after some agreed upon duration, we're going to kind of analyze the success of that. So, we were working, interestingly enough, like we got a lot more traction in Europe, spending a lot of time over there, a few trips to the Arctic, which was really cool.
Oh, that's fun.
Yeah. A lot of some exotic travel that I miss. I love it when it takes like 7 planes to get somewhere. And really like test it out. So that first year it was going pretty strong. And then there was kind of a dip, right? So if you've ever read Crossing the Chasm,
Mm-hmm.
you have a new technology product. There's a moment where you have kind of an early set of customers, but these are customers that are willing to take a risk with you. So these are customers that like they'll try any new technology sort of thing, but you're trying to get to like an early majority market where it becomes, you're buying this not just because you're interested in testing new tech. You're buying this because there's some proven value there.
Mm-hmm.
I'm probably butchering the thesis of this book, but there's a chasm in between where you have to kind of go from one set to another, and you have to be really focused. And we could see that there was this drop off in the pipeline in terms of what we're able to do with construction. And it's still, by the way, we should talk about like, it's still a construction product, and our partners have like kind of taken
Mm-hmm.
the mantle for that and are doing some really innovative things and kind of changing the entire approach. But that was the moment when industrial inspection, which was our industrial use case
Mm-hmm.
of using the robot, with like thermal imagery, acoustic imagery, and computer vision models like gauge reading to just kind of go around, again, a physical agent that's this like background QA/QC process, to kind of fill the gaps where fixed IoT isn't doing the job, to maintain uptime in factories. That exploded.
Mm-hmm.
And so back to Crossing the Chasm, if you're going to get across that gap with a new product, you need to find that market and you need to just focus on that. So that was the point where we said, okay, let's work with our partners in the construction industry, specifically at that point, Leica Geosystems, Drone Deploy, and Field AI, I think, was really just coming out of stealth, and doing some super interesting things today. And the core business at BD with Spot should focus on industrial inspection. And that's really been hugely successful. That's also when I moved into product management. I kind of moved out of construction business development into software product management for Orbit.
Brian, I think it's pretty fascinating that this pretty famous robot that we all recognize, I think Shaq was on stage with it at the All-Star game the other day, is you guys are angling it towards actually making buildings better. So I think one question that I would have, and maybe a lot of people would have, is why is the construction industry in this place in the first place? Like, obviously robots, can make things more efficient. They can run at night, but are there other limitations? I think you hinted at them that are causing construction to maybe not be where it wants to be, especially when we're trying to remake and build all these large projects.
Yeah, I mean, I think you have to separate I think there's one space, which is the whole product solution space, which is how do I take a technology that's a really good point solution, like, mobile IoT, we can call it.
What's IoT?
Internet of Things, a mobile sensor, like that I can put a sensing device that's internet connected on top of a physical robot agent and have it move through my environment. So like everybody's kind of, yeah, that's exciting. That's an innovation. But to make that a whole product solution, you really have to think about the kind of upfront piece, which is how do you program the robot to do what it does. Because even though it's an autonomous robot, you also want the programming to be as little labor as possible. And then on the back end, as you get information, whether it's photospherical information, video, laser scanning, do you have the pieces in place, one, to analyze it at the rate that you're collecting it, and then two, for that analysis to be meaningful for your bottom line. So you really have to kind of build a business with this technology. So I think that there was the autonomy side limitation, which is the robot is essentially teach and repeat. You have to record an environment, and in construction, that environment's always changing. It's a super hard problem. This is where somebody like our partners at Field AI are doing exploratory autonomy, which is let the robot loose in some contained relative volume of space and record as you go. Pros and cons, differences in how reliable these things are versus how long it takes to set them up. We're very reliability driven, like this thing needs to work all the time. And then the back end problem was kind of the analysis problem, which is like, okay, if I'm scanning every day, nobody really wants point clouds, right? They're a means to an end. You don't really want or care about the robot. You don't want or care about the point clouds. Like, you just want to know, like, is there a wall there that wasn't there yesterday? Because that impacts the schedule.
Point cloud is just XYZ color. It's not going to tell you, hey, this is a wall. Hey, this is a pipe.
Right.
Toilet.
So I have a good friend of mine, Stuart Maggs. So back in my WeWork days, he had a company called Scaled Robotics. And there were a couple companies at the time, and they were like reality capture companies, but they knew to attract eyes and get investor money, they had to like have a robot. Doxel was another one of these, and Doxel and Scaled ended up pivoting to like pure software because anyone who's sane stays out of hardware. So he was at WeWork, and we were talking about, at the time, the use of the robot itself, but also the software behind it, which was to understand that, like, this group of points is a wall, and this group of points is a carpenter's backpack, and we don't care about it. Like, it's not, what's FF&E, and what's like a trade, and what's the superstructure of the building, and all that sort of thing, so that we can ask questions of the data using the language we use in the business side.
And it's a remarkably hard problem.
It's a really hard problem. I mean, I think the success and proliferation of really advanced 2D computer vision technology, like image-based stuff, has kind of made people trivialize the 3D problem. But it is a very hard problem to kind of look at a bunch of points and say that, like, that represents a thing in the world that we have some frame of reference for. And in the context of like the construction business, not only like that's a wall, but that's like this family of wall in my model that's scheduled to be done on this date, right? So you're trying to connect a bunch of different information sources, and it's a tough problem. And they were doing some really cool things with the segmentation of point clouds, which is the recognition that this piece, this wall, is different from this piece, which is floor, and breaking them out into like sub.
Well, that's like the first step. In order to take all of these points and turn them into things, you need to first be able to say, hey, this thing is different than this thing. And then there's a secondary process to say, this thing is this.
Yes. So, and then like, okay, what do you do with that? And sometimes you're trying to reference like, oh, I have a 3D representation of this, I don't know, chair. And I can find the frame for that chair and insert an instance of that chair, or not, right? There's all sorts of ways you use that information and process that downstream.
What we would do, say, matching a 3D model into its position in that 3D point cloud.
Yeah. So there might be some generic classifications of objects in the world where you want to try to solid model over top of that, and it doesn't necessarily have that data layer. Like, I'm going to try to fit like geometry primitives to a thing, just some arbitrary piece of geometry. But more often than not, we're concerned with things where there are already three-dimensional representations, and we're basically instancing that object.
So you already know what objects are there. You're just trying to figure out where they are.
you know what objects are supposed to be there by a certain date. Yeah. And you're trying to understand which ones are there and if they're in the right place.
Well,
Yeah.
I guess like for construction and an industry that's still mostly working off of paper, this whole process is a remarkable amount of effort to get to something that a field supervisor is doing with an iPhone and photos.
It's super tough. Yeah. And so Stewart's company, they pivoted to pure software. They were called Nazca AI. And then now Stewart actually works with Field AI.
Mm-hmm.
So now, okay, that's an illustration of like Field AI understands there's a whole product problem for construction. They're working on the autonomy piece with a different approach, and they're working on the analysis piece with a different approach. And that, that sets them up to try, essentially the whole point of this conversation, to try construction again.
Mm-hmm.
To try to come at it from a few different angles, change up the recipe a little bit and say like, is this the whole product solution that provides business value? So that's all the whole product problem. Then there's a problem with the business of construction.
Let's talk about that problem. Because I mean, we're filling the chasm right now.
I'm already.
So why is this? Why is this put so deep? Why can't we?
I mean, it's important. It's an important question to ask right now because everyone wonders why we can't build stuff. It's literally on the ballot in 2024. I think it's going to continue to be part of our national conversation moving forward. So, you guys are going at it from the angle of technology, but potentially there's some latent issues that I think we need to address as well.
Yeah, for sure. Like, why is the business of construction so special? I guess is one way of putting it. I mean, so when you deliver a building, there are a lot of different stakeholders that have to be orchestrated to do that. It is a collection of like largely services, people providing MEP services, architecture services, structural services, and coordinating that and like with potentially conflicting incentives.
Mm-hmm.
Like not to disparage any subcontractor, but just conceptually, I might make more money from killing you with change orders than I would from just trying to deliver the project as efficiently as possible. You're trying to maximize the services you're offering. In theory, your business isn't about getting a building done as efficiently as possible. It's just about maximizing how many services you can charge for. That's a cynical take, but that's part of the way the business works. And then somehow in defiance of God's will, these 15 stakeholders end up building a building. And so there's so that's just the business model in terms of how many parties are involved and if their incentives are aligned. And then there's the design bid build model, which is, the fact that there are people who come up with designs, propose prices for that, and then other people who are yeah, that's a good price, and I'm going to take that information, I'm going to go build it, versus something like design build, where you're actually kind of involved in the whole process, and other business models where you're saying everybody should just sit in the same room, we're all one team, and we should extend ourselves into the construction process and not do an information handoff. I'm design intent only as the architect. I'm only locating things in the world. Here's a bunch of drawings that abstract that. You figure out how to actually do means and methods and get that built. So that's another thing that I think complicates the business. And also as part of both of those things, who's the customer for a new type of construction robot? Am I selling the robot as a product for the general contractor to buy because they're orchestrating the whole process? Or should my robot product be a service that I provide to the general contractor or to a subcontractor?
Mm-hmm.
Well, if my robot's a service, should I just compete as a subcontractor? If I'm a company that builds a layout robot, should I just be a carpentry and drywall contractor that uses robots and outperforms my competitors through underbidding because I have this robotic technology? I think unfortunately the model ends up being try to sell something to the GC because they have the biggest budget and the most power,
mm-hmm.
even though that might not make sense in the context of how the business is done. And I think like we're at a moment where people are still asking this question and trying to understand how to move that business model. I mean, there's some success stories out there. I think like Dusty Robotics and Layout Robotics in general have been pretty explosive. And that model has largely been a service model. Sometimes that service model is kind of hand in hand with the sub, and sometimes it's still working directly with the GC. Also, like, no one trusts each other anyway. So, like, let's say if the subcontractor, like, that is responsible for like laying out the walls, I'm a carpenter and I'm laying out the walls on the floor, and like I use the robot to lay this out. Well, maybe the like general contractor wants to use his general contractor robot to check that the first robot did things right. Which was, I remember having this moment at WeWork. Who was your colleague?
Jared?
No. Let's just list them all in the order of their salary from ascending to.
Ooh, I didn't work in HR, so I don't have that proprietary for me.
Your hotline BIM.
Oh, Grant?
Grant, yes.
Yeah.
I remember sitting down with Grant and having this like epiphany, because I was like, we have these like data rich models, we have all the takeoffs for everything, we have all the locations for everything. Why aren't the subs using that? And he's like, they just don't trust it. They are legally responsible for their scope of work. No matter how sophisticated we are and how much information we have that we trust and present to them, they don't care. They need to do it their own way, which might be with like pencils and paper, for all we know. That's not to say that that's the wrong attitude necessarily, because the sub or the trades in the field often have intelligence that the architect don't have, and that's okay.
But they also have to guarantee that work. They're ultimately responsible for the result.
Right. And I just remember thinking like, well, then how can any technology help build a building if that's the attitude? But that was also partially why I was really interested in reality capture. If there's a relationship between all the stakeholders, where you have a set of stakeholders who are really working design intent, like we're modeling this thing to the best of our ability, that information gets to the field. The field says, I have additional intelligence and expertise to augment this, to actually do the thing. I'm going to build the thing, and maybe it's built slightly different. Oh, well, reality capture is the way to then close that loop back to the design intent people. Okay, now their model updates with respect to that. And then you keep that cycle going. And that to me was always why reality capture and its automation through robots was so important to try to change the construction industry. Because I remember, like, again, at WeWork, guys, it was such a great learning environment. Like, there's no doubt about, like, the having a vertically integrated company allowed you to, like, be in the field and then, like, be working on software and back and forth. And I remember we have all these sophisticated like wall layout tools, and we're using and then we had like an app to like sync that to laser layout and doing all this stuff. But then like the guys in the field, they just know more. They've just done it more. It's all they do all day, every day. Oh, like there's actually a door jamb here and that needs to offset, where this wall ends. And, the architect just missed it because the architect's not perfect.
The floor's not flat. You got to shim it. So the sliding door.
Totally. Like, yeah, just the physics. Yeah. Like, yeah, we haven't mentioned that physics. And they would redline the hell out of these drawings. And I'd see like stacks of redline drawings. And I'm like, none of this is going back to none of this is making it back to the architect. Or if it is, it's like painfully manual. And so I just started thinking it would be nice. Layout robots are a great example too. If the robot's the one doing the layout, then there's a digital record of what it's done that could be sent back to the designer, because documentation should be a living thing that moves through phases all the way to ideally operation. Like it doesn't stop. Like it's a life cycle tool. It's not a life cycle tool because I think largely the siloing of contractual responsibilities and liability. Like, well, okay, if I, the architect, have BIM all the way into operations, what responsibilities am I taking on? Although there have been some like really interesting innovations out there in terms of both architects, but I think primarily GCs and how they work with owners and extending their scope into building operations and kind of going from BIM to FIM, I guess, in that sense. But these technologies, there's no reason for them to be limited to design intent, to construction. Like, these are life cycle technologies. And if people can be entrepreneurial and figure out ways to modify the business to allow for that, I think that's really when you start to see massive value from that. And so I have a feedback loop, and that feedback loop can like live on through the entire life of the building. So that's like the most optimistic view of like, that's where this technology could go. That's what's so exciting about this. That's why this stuff is worth working on. But it's also, that's why this is so hard. And that's why this will take such a long time.
So I guess, will that change? Like, we're architects, we're techno optimists, we're like, okay, all this can magically happen. We have the technology, we have the will. The only thing standing in between us and this magical future is the business model.
Mm-hmm.
When is that going to change? Are we just going to be in this deadlock forever? Do we see it changing? Is it going to ever pick up?
Yeah, I mean, I think a lot of this stuff will happen, but it will happen very slowly because the market has to really, there have to be market pressures to force it. Mm-hmm. And a lot of these things are potentially big, painful changes. I mean, BIM itself, like, has BIM been fully like adopted? Like, has that saturated like the way we build? Not exactly.
There's a lot of saber rattling about how expensive Revit is.
Yeah, like it's still a painful process for a lot of businesses. It's not this natural thing. And I think maybe part of the problem is that we just expect instant gratification. I don't know. I'm trying to take kind of more of an optimistic tone because, in other podcasts have just been like, it'll never happen. The odds are stacked against us. But like, there are like little things that will happen, and like, the market's always right? Like, there will be certain pressures exerted, and if it's really necessary, then you'll see it happen. But there are a lot of parameters there, like the cost of labor and the various other costs of doing business. And also something we haven't touched upon too is the efficiency of the kind of R&D outfits at these companies that are kind of charged with the task of finding the new technologies and adopting them. The adoption process itself is like a minefield. So imagine like, well, you probably can imagine. We've all been involved kind of in this, but like being on an R&D team and what do I want to work on, right? Like, there's just this buffet of new technologies, whether it's, natural language, LLM interfaces, or robots, or VR, mixed reality. Like, there's just never ending. It's cool. It's great. Like, it's an exciting time. But if you're charged with adopting, like, you get overwhelmed and you get unfocused. So, the skill of clearly articulating business problems, I think, is a really crucial one. Whether it's coming from the researcher or the business organization that kind of manages the research agenda. And frankly, I think it's a weakness in the industry. Like, I think a lot of the research groups are just overwhelmed and kind of unfocused on the problems they're trying to answer. I think part of that is because the business is so complex. What's the most painful business problem in construction? Go, right? Like,
but it's also very unsexy, right? Like, you're a part of the specialist group, you go out and make presentations to other specialist groups. They want to see something cool, something flashy. But in the business, I remember us doing this on BIM ops, trying to make tooling, and it's like, the thing that the architects actually need is a button that automatically scales your viewport.
Yeah.
And like, you go out and present that and everyone's like, okay, that's cool, but like, that's the thing that actually has business impact. But
right, and then the CEO's like, I need to show how amazing we are at like trying all this time. Right. We're seeing this today, right? Like, all these companies like, I need to show that I'm using a humanoid robot to show that I'm a relevant business. And it's like, I think that will solve a lot of problems. That's the line of work I'm in. But yeah, no, I totally think that you have to market innovation. And when innovation's primary purpose is marketing, especially externally, you're going to lose some of the focus on like what's solving business problems, which are often unsexy or misaligned with stuff out there. Oh, you know what? Nothing that the venture capital market is forcing down my throat is actually solving a business problem. How about I put out, RFP for what I'm trying to solve? And I've seen this, like I've had conversations recently with like the pharmaceutical industry, and they were like, no, we went to the robotics companies and we said, we need this specific type of robot for the type of work that we're looking to do. And I think this is yet another dimension to the problem, is that we are in a bizarro venture capital economy, which is like, it's not like this notion of like, oh, if you solve business problems and you go out and make a bunch of money. It's like, no, what you're doing is raising capital. You have a bunch of people with more capital than they know what to do with. They need to put it somewhere so that there's potential growth. So like the sexiest idea wins, and it completely like flips.
So what you're saying is,
yeah,
co-working was not a sound business that was going to solve the workplace problems of tomorrow.
Co-working was a sound business.
Listening to you guys talk, though, I think there is actually a profound value in what WeWork did. Okay, first thing is, Brian, what you're talking about originally is how contractors do things their own way. And then now we're discussing about how architects also do things their own way. Because when working in the built environment, you're iterating, but in a very kind of controlled manner. And, the resistance to technology we're all feeling and we're addressing here is real. I work with engineers who still don't use BIM. It's straight up AutoCAD 2010 probably. And it's just like lines and they're blue, red, and green. And, but I'm working on smaller scale projects. I'm not working on airports or on train stations. And so I think that there's also a scalar difference here where the bigger projects are going to get that sexy new technology. It's going to be those big, large construction companies that are going to want to feature the humanoid robot. But what's interesting about WeWork is that you guys working on small projects, but you had the backing of like a SoftBank and all these people working on what would probably be, mobilized towards much bigger projects. Yet you're able to use this whole suite of tools and develop new tools along the way. And then, of course, when it all falls down, you all go off to other places and do interesting stuff. So cheers to that. But I do think that there is some kind of value in being able to apply advanced technology to smaller scale projects as well. That probably WeWork was able to do that others can't.
Well, yes, totally. So, and before I get into that, I just want to plug AutoCAD 2006 was the greatest AutoCAD version of
all time.
Yeah, that's right.
We need to get all that AutoCAD 2016.
The Windows XP of AutoCAD.
God, if we could get those CDs now, I want to revert my Windows 11 back. But I think, to your point, Alex, we were working on quite small projects, but we had that scale horizontally. So a small, 1% improvement on an architect's time, on time in field, had a huge impact because we were just deploying so much of this stuff.
Yeah, can you find, this was the whole thing, is when is the built environment a product? And it's very often not, because 1,000 reasons. So, but when you can have something repetitive, like a co-working space, especially one that's essentially TI projects, refurbishments of existing office stock, you have a constrained problem, with massive scale potential. And this is why, there's, we talk about this stuff a lot, oh my God, it's an unsolved problem and nobody will ever break through. Marriott is just prefabbing like a boss. They solved it, right? They solved it for their business. It's not super sexy because they didn't try to Katera it, where it was everything, right? And this is the part. Okay, here's another dimension of the construction. What is construction? Is it residential? Is it big cultural projects? Is it spec real estate, which is by my general conception, because of my career, is just it's all spec towers for like some future tenant. So you're like X layers removed from the end. The end user's irrelevant, right? Like you're just creating space to be sold by the next person. And that also confuses the conversation a lot because it's like, well, I don't know, like chain hotel prefab is a solved problem. Really smart people who work at that company, and they created a lot of value with that. Like, we're looking at this broader problem of lending efficiency to like literally everything we could work on in an architectural studio or as a general contractor. And I just think that it's not necessarily wrong. That's how you can't necessarily constrain yourself to a particular type of construction, but it absolutely muddies the conversation. Building a stadium is not the same as building like garden style apartments. It's just, it really shouldn't even be called the same industry. And yet it's all construction. Like,
but are those, I guess, typologies or verticals where the opportunity lies? Like, say a Marriott who is prefabbing, they have tight control over the entire stack from design to construction. Is that where the opportunity for automation for robotics lie, when you have that much control over the total product?
Yeah, I mean, I think so, because of the common sense statement that like you can only achieve these big ambitious goals in increments. Like ultimately, no, I think it can be more expansive than that. But like, yeah, if you want to achieve something before you die, like you should constrain the problem. I remember at Woods Baggett, actually, we were getting a lot of automotive showrooms actually as like something that was coming through at a fairly frequent rate. And I remember like latching onto that and being like, what if we just went really deep into that problem and developed tools to essentially fully automate? This was, Andrew and I were just always like, our like refrain that was, I think, half in jest was like, Andrew was going to automate the design industry and I was going to automate the construction industry. We were both going to figure out how to do that somehow over time. But yeah, I do
in this lifetime.
Yeah, well, now I'm not so sure. I was young and confident. But I mean, even in the robotics space, we're always trying to say like if you look at humanoids and everybody's like, oh, the future is like, they're going to be humanoids on the street doing your shopping for you. And there's going to be humanoids in your house, cleaning up or taking care of you and things like that. And it's like, yeah, that could be really cool. Like there are scenarios, it could be horrible, but there are positive scenarios where that could be beneficial for society. Absolutely. Am I going to put like a humanoid in the house today? Or like, probably not. Like, I think the right place to constrain that problem is in manufacturing environments that have a long history of working with industrial grade robots and really understand how to adopt that. And the learnings from that will absolutely help us to move toward a society where, mobile robots are this kind of ubiquitous.
So can you help us, I guess, understand that difference? Why is automation and robotics so much more prevalent, so much more entrenched, and so much more useful in a manufacturing environment than it is, say, in construction?
I wouldn't say more useful. I would say more readily adapted and absorbed. And I mean, for all the reasons we've already talked about with construction, but I mean, you could also just latch onto the fact that the construction environment is not an environment. It's like an ephemera. It doesn't exist yet. It's being constructed. It's changing in huge ways. When we're talking about manufacturing, we're changing automotive lines, we're changing work cells. It's a much more, the superstructure and a lot of the services aren't really changing. It's like minor changes. And one of the many challenges of robotics is like perception, navigation, localization. Like, how does this agent move through a physical environment? And the more stable that environment is, the easier it is to solve some of those problems. And then from the business standpoint, these are also industries that are essentially premised on the use of industrial automation. So it's not like a shock to bring a robot into this environment. It can be a pretty big culture shock to bring a robot into a construction environment. Sometimes in a good way. Sometimes it's like really awesome to see people taking pictures and sending them to their kids and being proud that like, hey, this is like what I do is cool and interesting. Like, absolutely. Like if that increases pride in your work, that's a really cool outcome. But there's also the question of, can more of construction be industrialized? Can more of construction move on site and be done in a factory environment? Because it's like, does everything really have to be in situ? Because that is just like 10x minimum the complexity of getting work done. If, WeWork, this came up all the time. We're like, okay, we could, be on site and measure things and cut and figure out how to like put an object in place, or we could like mass manufacture. And we did. We actually, again, we like set up, I think there's like maybe one or two like news articles about it because it essentially coincided with, WeWork's, we'll call it change of business. But like there was a factory in New Jersey, like mass manufacturing the storefront, which is like the aluminum and glass interior partitions that co-working spaces are kind of known for, and was really like a brand element for WeWork. And the idea being like, there's so much efficiency gain if we take the BIM. By the way, that was a hard problem. Like the BIM to the manufacturing process, not the like, how do I take a geometric description and convert it to like machine code? That's easy. It was the business problem. How do I like put this into an ERP? How do I issue work orders? How do I track inventory? It's like, oh my God, these are way harder problems, because I'm coming from the like, oh yeah, like, let's just put a button in BIM that like makes the building. That's the easy part. The business.
That's just how simple it is. Just click the button, goes to the factory.
I mean, okay, so most machines there's a human readable text file at some point in the process. So anyone can write something that converts a geometric description in CAD or in BIM to the language that a machine uses to control its NC operations, as it turns out. But again, building the business around that and managing that through ERPs, through work orders, that was way harder. But the point being, like, if you mass manufacture these things off site, deliver them to site, construction becomes this game of logistics. And if I want to introduce new robots and new robotic processes and industrial automation, I'm doing it in this off-site controlled environment and not in the pure chaos that is a construction site. And I mean, I love that challenge technically of like mobile robots on construction sites, but like a lot of times it's like, do we have to make it so difficult? But there's a lot of difficulties in moving from field construction to modular construction as well.
Yeah. So part of what you're talking about is taking the work that's done on site, that's traditionally done on site, and moving it into a much more controlled environment, into a factory where maybe one guy is doing the same thing over and over again in the same space. It's a lot safer.
Yeah.
It's a lot more repeatable. You get a lot more accuracy, and that's almost like a manufacturing environment where it's a lot easier to introduce automation. It's a lot easier to introduce robots. I know, Alex, like you've dealt with this in California. Like, what is that resistance from moving work from the site into the factory?
Well, it seems like it's a political problem too, because you have basically unions of labor that have created an industry, that have control over that industry, and they don't want to give it up. I mean, it's the same as offshoring any industry, but in this case, you're offshoring to robots potentially. So yeah, like we've had construction projects in California that are modular that have faced a lot of headwinds, and then finally, basically, labor unions come in and say, we don't want this anymore. It's not going to happen. They lobby in Sacramento, and then it's much harder to get that either incentivized or even approved to build that stuff in the face of a giant housing crisis as well. So I think that's one of the things about construction is just like there's a culture around it, for better or for worse, and that culture has staying power.
Yeah, and there would have to be a very clear commercial advantage for like a sub to say, I, as the subcontractor, am going to make that decision and say, I'm offering these prefabricated services instead of these field services. And that's, they would really have to see obvious value from that. I've seen it blamed on architecture culture as well. I remember being on site with a European contractor, and we were talking about prefab. It was like a big residential project we were looking at, and we were talking about like the balustrades of the balconies, and they were like, "Oh yeah, like we had basically said like balconies are a big feature of all this European housing we're doing, and we're gonna set up a factory and those balconies." And we couldn't get any architect to agree to use a limited set of like balustrade. There's just no architect wanted to work with us, like because that we were taking their job away by limiting them to like whatever. You can have 5 or 10 options because that's what's at the factory, and you should have to like spec the fact. And I kind of it's like you're like, God damn it, architects, come on, like, but also like I get that, right? Like, what's the point of being an architect if you're just kind of like, oh, okay, well, it's so again, like the problem is that the architect is a different business or trade. Like that's the problem. So like, couldn't you somehow mash those things together? I think Intelligent City is maybe a good example of this as a business model where they're like, okay, we're going to make timber products for construction, and we're going to have a factory that makes it, and everything's going to be premised on essentially like a parametric design language. So part of our product is a constrained set of options. And you try to do this thing where you're like, there are 3 types of walls, but they have like some parameter domain, right? Because we've got this all hooked up to some, whatever, Grasshopper or custom software in the background. And what's cool about that is that that's also a design for manufacturing approach. All of our, we'll call them parametric options, mass customization options are tied directly to what we are able to manufacture on the floor. So we've thought about those constraints. So the design language is premised essentially on what we're capable of manufacturing in this facility, but it's all, again, like it's all one team kind of working together. And the design language is just about what's possible with these materials and these technologies.
So it's like by programming the constraints of the manufacturing into design upstream, you do give the designers more options in a broader solution space that makes them feel like they have some element of control and creativity, but you make sure that whatever outcome comes from that design team is producible in the factory.
Yeah, and you do that by hiring architects into your business, whether you are architects or not. Ultimately, like, how does Intelligent City fit into delivering a building in Canada? Like, I don't know exactly. But you do that by saying, I'm going to find architects and I'm going to find that skill set and I'm going to build that into my business. Like that's not a separate thing. Like that is part of the problem. And I think that's a really cool approach. I don't understand the nuance of that quite as well, but I like that. And again, I'm always I don't want to like beat a dead horse. I mean, there have to be innovative business models to drive these technologies. So I'm always kind of on the lookout for when that happens. And on the one hand, you can kind of say architects are being left behind. Architects aren't being left behind. Architecture, perhaps, as a kind of specialized discipline. Architects, super valuable, skill set. It just has to be put to an entrepreneurial use in that sense. But I love that combination of like, okay, we're bringing designers into the business. We're bringing like computational design. We're building custom software for the design space. And like you said, the design space is designed for manufacturing. It's premised on our manufacturing capabilities. That's awesome. That's super cool. But again, you can't do that for all of construction. Right. You're doing that for like a timber product for probably a certain scale of housing.
So Alex, like you're in academia, like is this something that I guess in school people are recognizing that there's a difference between architecture and architects, and these 2 things may be applied differently in the real world?
Yeah, I think people recognize it. I think they use that explanation as sort of an excuse for why architecture school and the training isn't as viable as it used to be. People like yourselves who have found your own way, not through any assistance of your educational institution or your alma mater. But I do think we recognize that, like you're saying, Brian, there is a distinction between the process of, let's say, architecting and then actually producing buildings. And right now, I think the production of buildings, especially in America, is really stymied. It's quite it's quite constipated. And so anything that can move that forward would be helpful. But what I want to come back to also within our conversations, what you said at the beginning, where the incentive structures are all misaligned. Like the architect wants to deliver the beautiful building. The developer wants to produce the real estate product. The contractor basically wants to get paid. I think that's one of the major issues. And what you're saying here is, what if you brought the architect in-house? Maybe what if you brought the contractor in-house? If I actually think back to places where that works, you're talking about like authoritarian states that have those capacities because they're all like state-owned enterprises. Or you're talking about a place like Japan where they're not in-house, but they all fit within this umbrella of like, we're going to produce Japanese culture. Or Europe can be an example of that too. But so I do think that like, however, we're all going to have our own things that make us tick. You know, we're all going to want to pursue the things that make us get out of bed and get going in the morning. But if we can move that dialogue, maybe in school, maybe in the trades, or maybe in profession, towards some at least acknowledgement of what other people's incentives are, I think that could help us just do more stuff probably.
Yeah, and there's vertical integration. There's also owners kind of building teams where they're like, oh, like Morphosis and Zaner work really good together. So we're going to keep using them over and over again and kind of exercise that relationship on multiple projects. The counter argument to that is the kind of like, capitalist market pressures argument, which is like, people just aren't going to try as hard if they don't have to like bid for the project. But I think, as with all of these things, anytime you present a binary, like the two ends are both wrong. It's somewhere in the middle. And yeah, it's a super tough problem. Like, how do you get competition and people not kind of like going for the lowest possible, standard? Yeah, I don't know. It's a tricky one.
Well, I think at the very least, technology forces someone to rethink things, right? Like if suddenly there's a robot on the construction site instead of a bunch of dudes, then you're gonna be like, okay, what do we have to do to make this work in our market, in our economy right now? So I think that regardless of what you do, I am not like the type of person who always advocates for disruption for the sake of disruption, but also like disruption and advancement for the sake of agitation to cause us to rethink and start to reconsider if what we're doing works or not.
Yeah, and I always thought about this too, about like, well, who's really in charge, right? It's like the owner is in charge, right? I would say
Maybe.
Like they're the ones who hire and fire everyone at the end of the day because they're the client. How educated are they? They don't know. Like I've been on projects where the owner was doing a complex geometry for a building for the first time, and they didn't know what they were stepping into. And when they're looking at bids and they're looking at the cost of that, I'm like, if you've got a twisty tower, normally it's like you go with the second cheapest person, right? The cheapest, it's like that's sketchy. The second cheapest is like, okay, that's where I'm going to get the value. You go with the third cheapest if you've got a twisty tower. Like you want to like, you really like, and I just like, that was an example I remember where I was like, the owner is just a little bit undereducated in what it takes to deliver a building of this complexity, and the things that they VE'd out are going to really hurt them. They did, I think, go out of business for that particular project. It was like, the signals were not wrong. Like, and so I think that's part of it too. That's why I always thought I know like Zaner, I mentioned Morphosis and Zaner. Zaner does, sheet metal fabrication, and Morphosis does a lot of cool sheet metal facade work. And I always thought that story was really cool because it was an example of like, it's the Avengers of architecture. We're going to keep putting them together, but they're not like, neither party is going to get lazy. You know, they're not going to start like, oh, well, we got this in the bag now that the owners or the, you know, like trust us. They're still like highly motivated people working. And there aren't enough of those stories, I don't think, because there's just this massive jumble every time you go out and bid on work. You just end up, it's just that awkward thing where like it's like you're in school and you're assigned group work, and like every time you just get like the most random set of classmates, and you're like, well, I guess I have to build a building now with like this guy. Like I'm definitely going to do all of his work for him. Or her. She could also be a terrible group partner. So
Everybody's
like,
included.
that's right. This is an inclusive underperforming.
I'm laughing
There.
because I always I always assign groups, and then there's always that one group that's like, I can't do this. I can't do this. I say, hey man, this is what it's going to be like in the real world. So thank you, Brian, for confirming that this is what it's like.
Totally. Yeah, but it's a really weird way to do business, to be like, oh, we're gonna work with these random other 9 companies to build this building, and then like whatever, like that project's done, and then one day later, 9 different people. I've learned nothing. I have like there is no institutional knowledge to pass on to the next. Oh, and it's you know, it's a cultural center, and we just did like a tower, an office tower. Like again, like there's so much variation, and we used to say at WeWork, like the building's a product, the building is a product. And yeah, obviously that was the ethos for like the WeWorking product, but man, that is not true. It is not a product normally at all.
So I want to bring us back to robots, where we started this conversation.
Yeah, we haven't talked about robots enough.
Well, we talked about why we don't have robots. So let's imagine a future where we do. When I'm assembling this potentially underperforming team, when would I hire a robot instead of someone?
Oh my God. I mean, yeah, what are robots good for, right? We're also, I think there's a conflation right now of like, what is software for automation? What is AI? Like pure software AI? What are robots? What are robots with AI? What are all the different kinds of AI? So things are, as usual, a little bit more nuanced than we tend to talk about them. So like, what are problems that robots are good at solving? Like the focus with Spot for doing the reality capture in the work in place, you know, that was a real problem we were hearing from customers, and I do think is a real industry problem. But it's also because we were looking for a mobile sensing problem. There are mobile manipulation problems. Robots physically building things. Are there scaled examples of this in the world? Not really, because it's a hard problem. There's a lot of trials and attempts. But having a robot that has to touch something needs to be at the very least sub-centimeter accuracy, if not, we're talking, millimeters. A robot that just needs to take pictures or perform laser scans, I mean, you want to hold it to a high standard, but like there are cases where 10 centimeters might not matter for the output. So the precision of interacting with the world and touching something, being able to grasp something, it's just a bajillion extra layers of complexity on top of that. So again, if you go offsite, you can use fixed industrial automation, fixed industrial robotic arms, and like a lot of those problems can kind of be solved in that way. A thing that has to move through the world, perceive the world, understand instructions, understand intent, manipulate objects, put objects, do assembly tasks. I mean, that's really tough. So I think where we're at in construction is we've got robots for reality capture. The drone. Like the drone's a pretty successful robot for like aerial reality capture. Interior reality capture, that's where Spot's kind of being leveraged a lot. But that's still, I think, like a domain that would still benefit from advances. We've got layout robots. That's I think hugely popular. All of these things, I think, they're technically non-value add, right? The goal is to get to value add in the like manufacturing or product sense, which is I'm adding a physical thing. So value adding construction in that sense would be like, I'm putting like a framing element in place and fastening it. Like that's value add. Laser scanning to know how to plan for that is not value add. These are valuable, but they're not strictly value add.
Mhm.
Laying a line out for where I put that thing is not value add. It's like, well, the robot should just have the BIM in its brain, right? It should just know where to put things. So one thought exercise I always encourage people when we're like, okay, what are robots useful for in construction is to say, if you could build everything off site, what's left to do on site? That's where I would focus construction robotics business. So in theory, it's like, okay, you still have to do the foundational work. You still have to do all the like groundwork. You still have to like excavate and do earth moving and pour foundations and build a superstructure. The superstructure elements themselves could be and often are prefabbed and assemble those. So you're really talking about like, there's like this kind of like, there's all the earth moving stuff. So there's a whole business around that. There's like retrofit automation for excavators and bulldozers. Some of that stuff is getting built into OEM equipment. There's concepts for cabless equipment. So there's a whole industry there. And then there's like superstructure. So there's like robotic crane technology. So how do I understand like where my storage yard of elements are? How do I pick the right one? How do I put it into place? Sort of thing.
So there's a lot of problems, I think, within construction that you're naming where robots are coming in. They're maybe solving some of these piecemeal problems. Like, do you see this as kind of a smooth evolution? Like, we'll just get more and more of these until we slowly realize, like, hey, it's taking 10%, 20%, and 30%? Or is it going to be, I guess, like a punctuated equilibrium where, like, all of a sudden, all of these things come together and we're going to be like, holy crap, like, half of the things we do on site are now automated?
Yeah, I mean, I don't know. I think that it will be a long, smooth is probably the wrong word, striated maybe process, non-linear perhaps. I mean, like, there's a lot of okay, if we jump to earth moving, like, okay, we're trying to scope problems where robots add value in a world where we are maximizing industrialized construction. Because otherwise, you just have this generalized robot problem where you're like, I need this fully capable humanoid to just come in. And we're just talking about labor replacement. We're just talking about building the same way we do today, except replacing people. That's so boring to me. Like, I don't like that future. So if we kind of scope it differently, we do this thought exercise. Okay, like, we still need to do earth moving. Like, we can't off-site earth moving. You just drop a new layer of earth on top. And like, so right now, like, we've seen a lot of businesses doing really interesting things with like aftermarket autonomy modules. So you put like, do you remember those snail carriers that like our parents used to put on their cars in like the late 80s, early 90s? Okay, this is a thing. It used to be like, there used to be less options in the market back in the day. It was like everybody, there were only two types of like, it's when you put extra storage on top of your car. So, and the brand I think was Snail. The logo was definitely a snail. Anyway, we'll look it up. But it's like that. You have this shell that you fill with perception modules and safety modules and everything you need for autonomy, and then all your connectors to the machine control, and then you like put that on top of the thing, and that allows you to take any machine that already exists and turn it into a robot. But they still have a cab and a seat,
right?
And an operator can still override. And there's all sorts of variations in between. So there's like, I've been in excavators where what's automated is the level of excavation because you have a design model for how deep you're supposed to dig. So you're still pointing and you're still digging, but you're not setting the depth anymore. That part's automated. So it's kind of like automatic or manual to automatic driving or something. But then there's a future where as these things get more and more automated, you might go back to the OEM and say, we don't need the cab anymore. Now there's never a reason for a person to be physically co-located with this machine. And that person will be at a computer station somewhere, and they'll be overseeing many machines and tracking their progress and kind of like jumping in and directing. It is fleet management essentially at that point. But that'll be like years, right, of like development, and we're still kind of we're not in mass market adoption of the aftermarket modifications, but like it's happening and it's growing, and there's clearly advantages to it. And the other thing we haven't mentioned is this idea of a labor shortage, which is to say, like, yeah, it would be nice to automate someone out of a job if there was someone to work the job in the first place, kind of like mentality. And I try not to preach that too much, because I think that is one of those self-fulfilling problems. It's real. There are real labor shortages. It's hard to hire for those things. But the more you talk about that, the more how you talk about that, well, the inevitability of that is like the automation of those jobs. Okay, well, now why would a young person go into that job? So I think you kind of have to be careful about how you talk about that problem. But nevertheless, there's an element of truth to that. And that is something that if there is no greater pressure to adopt, then I cannot hire people to get this work done. Now I have to figure out how to make one person do the job that 10 people used to do.
So, knowing what you know today, having talked us through all the myriad of problems that are blocking robots from being adopted in construction, if you were to start over, young Brian, maybe early WeWork, maybe pre-WeWork, and you were starting over, what would you do differently today, and what problem would you tackle first?
Man, I'm like kind of like existentially and philosophically opposed to that thought exercise. I don't know how you would live a life over again, but I don't know. I mean, because I think part of the joy of this career was that it wasn't so, deterministic. I wanted to be just a regular architect, and then forces kind of pushed me into learning technology, and I thought that was really interesting. And then I started to see the value that could add to architecture and keep me in that domain. And, one thing led to another. If I were to start over, I would definitely get an architecture degree over again. Like, I think that was a massively valuable experience. I think that education, at least at the University of Cincinnati at the time I was there, right? Let me qualify this.
Well,
the world is changing.
Just that bit and send it to all the architecture schools.
Yeah. Shout out to Cincinnati. But I mean, that was a great education. I loved it. And even now, looking back, I see the value in that. It was like a lot of those things. I think it kind of, there probably weren't enough voices saying these skills are transferable. You don't have to be an architect, especially at Cincinnati. And it's not a bad thing, but like, it was about the co-op. It was about getting experience, and like everybody, they were proud that like they graduated people and people became licensed architects and people practiced that. And I don't think there's like a problem with that kind of culture at an educational institution.
Are you licensed?
No, I tried to go for licensure, but I kind of felt like as a technology specialist, you either have to essentially stop being a technology specialist and be like, can I be a normal architect for a couple years? Or you have to kind of like fake the way you get your, what were they even called? Your
the carve hours?
Yeah.
Yeah.
So you can always find people to like sign off on it, or like they'll let you go on a field trip and pretend to be a normal architect. And I became kind of frustrated. Even early on, actually, in the co-op program at Cincinnati, I did an internship with a firm where there were no licensed architects at the firm because it was a boutique design firm. Those points didn't count.
Right.
I did another one. There was some other weird asterisk where like the points didn't count or the person didn't do the paperwork. And then I felt like I was like forcing it again when I went into practice. And I was like, this is so almost humiliating, like the way I'm trying to like force this thing and I was like, you know what, now I'm interested in what I'm doing. And if that means that I can't be a licensed architect, then that's fine. I'll just be whatever this is. And that's hard, I think, for a lot of people who invest in the career, because that's the classic trajectory. And there's a lot of pride, as I think there should be. Those tests are really fucking hard. like you go to school almost as much as a doctor to get paid 1/10 that what a doctor pays. You put in all these hours to get this training, to take these. It's serious. It's really, people who are licensed architects are hugely skilled. Like, you can't fake your way through that. Like, that is an honor. Like, I get that, but there was just no way to do it in a way that felt kind of like worth doing. So I gave up after a certain amount of time and just kind of embraced what my career was. And, you know, thank God I gave up, because, like, I mean, it'd still be cool to be like, yeah, you know, I'm licensed, but like, you know, I ended up going so far away from that trajectory that that hasn't mattered. And, you know, I don't know how things have changed today. I don't know what the balance of power is with NCARB and licensure. I don't know how flexible things have got. I imagine it's changed in some capacity. I haven't kept in touch with it, but at the time that was a big frustration. Yeah.
So we've gone through your history, or rewritten some history. But now that you're a distinguished product manager at Boston Dynamics, what's next for you? Are you going to become more distinguished?
Well, this is an individual contributor track that is kind of that you would see adopted by like engineering-led organizations, versus like a regular like management track where you become like associate director, VP sort of thing. So I don't know. I've been fortunate to have growth in that individual contributor role at Boston Dynamics. One thing I think is really cool about that is I get to work on cross-company problems. You know, when I think about how does a user, what is the UX for like robot task authoring? I get to ask that question across all of our robots and across all of the applications that we're thinking about doing. I get to work with a lot of different teams, and I get to try to, one of the things I talk about is like, because I love, you know, I love like the academic world, and sometimes I say like I'm a scholar of Boston Dynamics, right? Like you have to like study the organization and kind of understand all these different pieces of it, and then it's good to have some people in the organization that are kind of like the pollinating bees going around and connecting the dots. And I really enjoyed kind of that role. I don't know if there's anything that comes after distinguished. That might be it. I don't know exactly. But there's absolutely like still room for, there's so much more to do. Not just in robotics, but at Boston Dynamics. And like, we're just entering the like humanoid world. You know, this, you know, as things are going, like, you know, I'd love to work on this problem for my entire career. I think it's super interesting.
I think maybe this is one for the architects at home who are thinking about doing product management, something I feel like you're uniquely equipped to answer. Someone both with a lot of reverence for the education. I don't think, you know, you've said that I wouldn't go to architecture school again, but also someone who's really established himself as a product manager, right? So what do you think was valuable about your education that made you so successful as a product manager? And to someone, you know, maybe who's an architect right now thinking about making this change, what advice would you give them?
Yeah, I mean, I think a lot of it boils down to like design thinking as a way of breaking down complex problems, thorough documentation from every angle, these like architectural skills that are transferable to product management. Architects, I think, make really good PMs too, because you have design education. So like, you're not like necessarily like a UX designer proper, because that's its own discipline, and like, you know, respect to the things that they have to learn that are different, but like, you're not a professional designer. So you have that sensibility. You can think through problems from, you know, user interaction points of view. So, I don't know, like, I have tried to intentionally keep myself ignorant of any kind of dogmatic understanding of product management. I don't care. I know that product management is important
Mhm.
and like has a lot to offer businesses. I believe that. But having some kind of like gospel of product management doesn't really appeal. There's like a product management like LinkedIn
Yeah,
kind of
you're not
like
reading all the
corner.
Marty Kagan books or
Yeah, like it all kind of grosses me out. Not that there aren't valuable pieces in each of those things, but it just it becomes kind of theoretical and abstract when you fetishize it like that. And one of the things I learned about being an architect is how do you earn the respect of the other trades? Because they're like, oh, an architect is somebody who doesn't understand how to build things telling me how to build things. Oh, a product manager is somebody who doesn't understand how to build things telling me how to build things. And there's like a whole like memosphere of like how worthless product managers are because they're just like, I don't know.
But what if you just win a bunch of design competitions? That'll get the contractors respect, no?
I mean, you are producing work, I suppose. But so for me, it's been nice to have accidentally become a product manager. But I have noticed that a lot of architects do become in UX, product, kind of those things. And I understand why. And I still think an architecture degree is a good one. I don't know if there's not like a PM degree, is there?
Not yet.
Right? Yeah, there will be.
You wait till the theoretical and down the count.
Yeah. So my original title at Boston Dynamics was Construction Technology Manager. That doesn't really mean much. It was really a business development role that had like some sprinklings of like sales, product, marketing. It was really just like we need a domain expert to help find product market fit. And then kind of when I went into like true product management, aspects of that were like, I'm working with a specific engineering team. We're doing split planning. I'm writing requirements documents. And then like, I kind of got like Figma sick and became like very like UX oriented. Everything has to be like a prototype and a mock, but I love that. I'm like, this is the same way that I love the language of architectural representation, particularly 2D, as a hyper efficient abstraction of complex instructions or information in general. I like that about like UI UX prototyping, which is like I could write a 20-page requirements document, or I could just show you the literal clicks and picks of like what is the user journey and how did you move through this.
And engineers prefer that.
They eat it up, yeah. And also like oh, cool. Like you used a design system that already has like all of everything I care about, like the radius of the button, the color values, the text styles. Sophisticated organizations will link their Figma component libraries to their actual, web component libraries in their repos. So like, no, they love it. And even cooler than that is some of them get really into design. Like who aren't necessarily natural designers, and they're like, oh, I can use Figma. This is pretty easy. And like, I'm going to use it to prototype what I'm going to do and share with the team. And that's what got me the most excited. I think as we've grown kind of that culture, design systems, Figma, UI, UX, because we don't have that many pure UX people, but we have a lot of people with like cross-disciplinary interest. And, at first we were using Figma, and what was the Adobe competitor to Figma? XD. Yeah. So it was like, there's a little bit of that, I'm like over here using like Grasshopper and Photoshop in really like perverse ways.
Love it.
Oh God, awful. And then I was like, I think we should really align on, I think Figma is the thing. And then there was like buy-in on that. And a couple of us went to config and kind of like, how are people using that? What's a design system? And then came back with that knowledge and then like pretty rapidly built out a design system, got everybody in Figma. All of a sudden the engineers are like in the Figma projects and like doing their own stuff. And, somebody from like, I saw some insane presentations at config, right? There are people, it's like draconian design systems where it's like, we run an analysis of whoever made their own button and we send them to jail. Like, that's not what we're doing. Like, some people don't know how to use the design system or what a component is, but they know that they can rapidly create a visual and that visual gets to the point. And all the better if there's interaction too, because these things, it's not just the visual. But that's been super cool. That's been a really cool like journey we've been on kind of as a design culture at Boston Dynamics.
I think it's really
Yeah.
cool to just watch you see this problem, start pulling at it using, the hammers and nails you're used to, and then kind of switch tools as you approach the problem in new ways.
It was like, I was like, I haven't learned a new piece of software in a long. I used to like when I was like young in architecture, it was like every day.
Mhm.
Every day I was learning a new piece of software. I swear, like, and I was like, I haven't done this in a while. Like, and like, people will not shut up about Figma. So
Just for good reason.
for good reason, yeah. And it was really fun. It was like really pleasurable, to, like dive into something new, and then be like, oh, okay, that's like the value this provides to this process. And there was a little bit of friction at first. It's like not spitting stuff out as fast. But man, once you're cooking, you can keep design ahead of engineering, across products and across horizons. Like, hey, this is okay, we're moving into H2 of 2025, and this is kind of the mocks of what those epics are gonna kind of manifest as in terms of like software products, but also like, and this is what it's going to look like in 5 years. And it's all in the same language, and it's all in the same projects, and people can collaborate. You can set up your prototypes that you share to be like, oh, this is what it will look like in the future. This is what it looks like today, to understand that progression and how you are phasing requirements and phasing your product rollout. It's super cool stuff. And it reminds me of the original joy of learning parametric design software, learning Grasshopper, and like understanding like how just the way that scales your impact on design. And I guess like if we want to like bring this back to like robotics and AI, it's the joy for me is like the sum of the parts with respect to creative capacity, between humans and their augmentation, whether it's robots or software or anything in between. That's what's so cool, is that people by themselves cannot accomplish this stuff. Robots by themselves cannot accomplish this stuff. Us working together with these systems and with these technologies creates new knowledge in the world. And like, what better way to live a life than to like try to make something new? How rare is that? So I think that's what's been really cool about this.
I think that's a great inspirational moment to end on and pose our final question.
Okay.
Part of the reason we do this podcast, part of the reason this podcast is called Most Modern, is that we're trying to figure out what era we're currently living in. As we've talked about throughout this whole conversation, there's a lot of chaotic stuff going on. There's a lot of things to think about. And I do think you have a very unique perspective. So we would like to pose this question to you. What era would you say we're currently in?
Yeah. Specifically, hard to say. One of the things that's interesting is I think that you never know what era you're in when you're in it, right? And things are so much slower than we think. Like, I think about the fall of Rome.
Oh, yeah. I think about that all the time.
You should. So like, if you look at something like that happened over like, I mean, if you really look at like the entire centuries, right? And the people in those societies were not experiencing the fall of Rome. Like, it wasn't like this thing that was happening. They were just living life. So, whatever we're in something that I think is slower than we think and is more in the future than we think. Like, we're probably in the age of like dealing with, I would say, aspects of intelligence that exceed human intelligence, because I don't think we understand what it means to have something generally more intelligent than a human. I just think that's impossible. That's a philosophical question. I think unfortunately we are probably actually in World War III, which isn't to say I'm not like nuclear annihilation, but we are in that global conflict. Like, that is unfortunately already happened, but there's still agency we have to do something about that. Is that a good thing to end this podcast on? Or is that we're in World War III? That feels
That's the clip we're gonna open.
That
up.
feels off key to me.
If you can describe war as a positive thing, then maybe it's a good
It's a
thing.
positive thing in the sense that if you, and I'm just parroting this Zizek book that I bought at the Hamburg train station from the English book section a couple weeks ago. If you project yourself to like what's already the worst case scenario, you are more likely to make decisions that avoid that scenario. In design culture, God, what are we in design culture? I don't know. That's an interesting one too, because I feel like we were educated in like a kind of starchitecture phase, like the aggrandizement of extreme wealth through contorted geometry. Just always my job description. So much of what I did in architecture was, well, I'm trying to aggrandize someone's wealth through complex geometry, but in order to do that, I have to turn it all.
Well, you're kind of doing the same with robots now, right? You got to put the expensive stuff on the robots, or no one's gonna buy it.
Yeah. Now we're in. No, I mean, we're also going to see like low cost mass manufactured robotics too. I think it's a huge misconception. Like, it's crazy how fast this stuff is moving. It's a huge misconception that a hyper, I won't say intelligent, but hyper performative like humanoid robot with a bunch of AI policies running on it is going to be an expensive thing. I don't think that's true at all. I think a lot of this stuff is going to be commoditized pretty quickly. Hardware for sure. And you know, a lot of AI stuff, as we've seen with non-US competitors, is also like pretty quickly emulated, and you know, we can only build bigger, better data centers so much faster. So like all of that stuff is going to be kind of a level playing ground, and you know, okay, well, how do you differentiate yourself? You solve actual problems. Is probably beeping.
That's probably Jared's like, you guys are late for.
He's like, yeah, we're supposed to get drinking. So like, so I think we're like probably already in the era of like mass produced affordable robots that can do really insane things, even though we don't think we're there yet. Are we in the era of more efficient construction of any kind in any way, shape, or form? I don't know. I'm out of the industry now. I don't quite keep up to speed with like the problems that are being discussed. I know that energy modeling has come a long way. Material science is huge. We didn't even talk about 3D printing as like a, you know, as a domain of construction robotics, which is like growing at a pretty healthy pace. So yeah, I'm not answering your question at all by naming a specific era, but I think the takeaway is that we are already where, you know, we think we're going to be in the future, and it's just, it takes time to kind of realize that we're there, and it's hard to realize it in the moment.
Well, if I'm someone listening to this, I'm like, Brian, that's great. I want to hear more about robots. I want to hear more about the fall of Rome. I want to hear more about World War III. I want to hear more about, you know, these mass-produced, super sick, cheap robotics. Where do I go to find you?
Yeah, I think LinkedIn is probably the best, but God, what a boring answer. And be like, hey, this Twitter, I'm like, I have an account on Twitter, don't really use it anymore because, like, you know, well, we won't go into that. Instagram is like, you can find me on there, but like, caution, my Instagram is weird, and, you know, so, LinkedIn is probably where to reach out, and then I have a Linktree page. This is always that. I hate social media. I'm trying to like find me in the real world.
I feel like Brian is like one of these like LinkedIn on the streets, but Instagram in the sheets kind of guys.
Yeah, yes, absolutely. But I'm also like, this whole culture of like, how do you connect with me and let me list a bunch of websites? Like, I don't know, like, figure it out, find me. It's better to hang out. I begged you to do this podcast in person, because if I have to do one more Zoom podcast, I will kill myself. Like,
well, you're the reason we set this whole thing up, just for you, man.
Yeah. So, But yeah, just Google my name, you'll find me. There's only like a couple Brian Ringleys, so.
Well,
not that
you know,
hard.
be careful what you find. You might not like it.
Yeah.
Or you might really love it.
I really love it. You never know. You gotta try.
No, but thank you so much, Brian, and thank you, our listeners. If you're listening to Most Pod for the first time, please like and subscribe on
What a
YouTube.
weird first episode.
One of the greatest first episodes. Wait till you see our back catalog. But we're on YouTube, we're on Spotify, we're on Apple. If you give us a like and a subscribe, it really helps us find more entertaining and fun guests like Brian.
Most modern.
Most modern.
Most modern.
Most modern. 모스트 포던 팟캐스트.